Hello, good evening, students. So, let me introduce to myself first of all. Myself Narendra Kumar, and today I am just telling you about your chapter number 1 of 10th class, that is real number. So, first of all, we have to define the term real number. सो लेट्स सी बेटा किस तरह से हमने रियल नंबर को डिफाइन करना है. सो वी नो वेरी वेल इट मे बी डिफाइंड एज इट इज़ द सेट ऑफ रैशनल एंड irrational numbers. Is known as a real number. Then what are rational numbers? So rational number, the number which can be written in the form P upon Q, where Q cannot be equal to 0, are known to be rational number. For example, let's take an example of a number 2 upon 3. This is an example of rational number. Similarly, 0 upon 1, 0 upon 7, etc. These numbers are said to be rational numbers. Similarly, what about irrational number? So these are those numbers which cannot be written in the form P upon Q, where Q cannot be equals to 0, are said to be irrational number. Then after, we are taking some examples of irrational numbers. These are root 2, root 3, root 7, etc. And these numbers are said to be irrational numbers. So now in your exercise 1.1 of chapter number 1, class 10th, that is how to calculate the HCF of two positive numbers by using Euclid division algorithm. And we have already studied about the concept of Euclid division algorithm, and for that case we know very well कि whenever we are going to divide two numbers to each other, then where A is said to be a dividend and B is said to be divisor, and when these two numbers are divided to each other, then we'll use Euclid division lemma, that is by factor theorem. Dividend equals to divisor multiply quotient plus remainder. So this is our factor theorem. So from this factor theorem we are able to calculate the HCF of two positive numbers by using Euclid division algorithm. So let us take an example to solve the HCF by using Euclid division algorithm. So let's see, we are taking an example of question number 1, that is 135 and 225. And now here we want to calculate the HCF of these numbers. To find HCF of these numbers by using Euclid's division algorithm. And for calculate the HCF for these two positive integers or numbers, we are taking the concept that is by Euclid. First of all, let us check the greater value between the two. The step one is let us check the greatest value between these two. And here we know that 225 is more than that of 135. Then after we'll divide 225 with 135, and with the help of one table we'll write the answer is 135, 0, then 12 minus 3, that is 9, and again here remainder is not 0. Then by using Euclid's division lemma, we'll write dividend equals to divisor multiply quotient plus remainder. And since here remainder is not equal to 0, then again using the step 2. And for step 2, what we have to do, let us check the remainder of the above calculation and divisor. So in between these two numbers we have to check the greater value, since here 135 is more than of 90. So we'll divide 135 by 90. Then again 91 is 90, 92 is 180. It means 180 is more than that of 135. So we'll divide it with 91 is 90. So we'll get the calculation, that is the remainder again is 45. Then again by using Euclid division lemma, then what we have, dividend equals to divisor multiply quotient and again plus remainder. And since here remainder again cannot be equal to 0, then we put forward next step, that is step 3, and let us check the divisor and the remainder of the above calculation. So since here divisor is more than that of remainder, so now again using Euclid division lemma, dividing 90 by 45, and 45 2s are 90, and we'll get the remainder is 0 here. So therefore we'll use again by using Euclid division lemma, we have dividend equals to divisor multiply quotient plus remainder, and here remainder is 0. And in the last case we have to proceed this process until or unless we will get the remainder equals to 0. So with the help of 45 we are able to get the remainder 0. It means the whole calculation, that is HCF of 135 and 225 equals to 45. So this will be your answer. Thank you.